Welcome student, this is the second part of the carpentry shop lecture. In this lecture we are going to discuss different kinds of carpentry tools and the different safety rules that we take in the carpentry shop. The carpentry tools that we are going to discuss today are marking and measuring tools, holding tools, cutting tools, striking tools and finishing tools. We'll start with the steel ruler. As you can see, these are the pictures of the steel ruler, and both inch marking as well as the millimeter marking are there in the steel rule. And the one thing that you should observe, that is that the zero mark, there is no specific zero marks in the steel rule. Actually the one edge of the steel rule is considered as the zero reference. Okay, so if you have to measure any length, then you remember that it is to be measured from the one end. Okay, and the typical plastic or the wooden rulers are not used in the carpentry shop because they are not so strong, so that they can break very easily during the work, or they can easily damage over the time in the adverse environment in the carpentry shop, or there is a chance of moisture absorption in case of if it is a wooden ruler. Okay, so that is why this kind of rulers are not preferred in the carpentry shop. Next we will see another kind of measuring and marking tool, that is marking gauge. Now see here, this is the picture of a marking gauge, and as you can see that here one end you will find that some nail kind of a thing is there, so that it can scribed over the surface, so that it can mark over the surface, and there is a scale and adjusting knob, so that you can make a particular distance away from this edge. So the distance between the small scriber at the one end and this one edge, and this one edge is taken as a reference. Here as you can see in this board, suppose you want to make a line which is parallel to this edge, then what we generally do with this marking gauge, the one surface, this is the reference surface that is placed at this end, and this scribing end will make this length as 50 millimeter. Okay, so initially this 50 millimeter is set by adjusting this knob, then it is fixed, and then with respect to this edge it is basically moved, and you can get this kind of a marking which is exactly 50 millimeter parallel from this edge. So this is what is the marking gauge. Another kind of marking and measuring device, that is the Mortis gauge. In case of Mortis gauge, instead of a single scriber, there are basically two this kind of a scriber is there over the gauge, as you can see, and through this the distance between these two points, these two scribing points can be adjusted. Okay, so in this way what we can do, that two parallel lines we can mark with any distance we can adjust with respect to the reference. You can also adjust this distance. So this is what is the basic idea of the Mortis gauge. Next, another tool which is the tri-square. As you can see, this is L-shaped basically. As you can see here, this is what is the tri-square. This is the L-shaped tool, L-shaped measuring tool, and in this case what is the job of this tri-square is to measure whether two surfaces, two adjacent surfaces are right angle to each other or not, whether these two surfaces are square to each other or not. Okay, so this angle is basically 90 degree, and it is used to check whether two adjacent surfaces are at 90 degree or not. And there is another way we can also use tri-square to check the flatness, whether a particular surface is completely flat or not. That also can be checked by the tri-square. As you can see over there, if there is some waviness, definitely some pockets will be created between that tri-square and the surface, and we'll be able to identify that how much flat that particular surface is. Okay, now coming to the next tool, that is again measuring and marking tools, and which is the bevel square. And the bevel square is basically the extension of the tri-square, which is nothing but instead of a 90 degree that we have seen in case of a tri-square, now this angle can be adjusted. As you can see that here is a hinge joint, so you can change the angle, and it is used to measure the angle or check whether two surfaces are at a particular angle or not. Okay, so that is called bevel square. Next, this is again another marking tool, and this marking tool is it can be marking knife, or it can be scriber, because with the help of pencils and pens we can use to mark over the timber surface, but the marking knife and scribers are basically used to make it permanent. Otherwise there is a chance that during work those pencil lines may be rubbed. That is why this kind of marking knife and scribers are used. Now coming to the holding tools. So after measuring and marking, it is important to work on that particular job. So for that you have to hold or fix that tool, and then you have to do some cutting operations or whatever. So to hold the job, there are different ways, different kinds of holding facilities are there, so that we are going to discuss. So first of all, you see that working bench. Okay, so as you can see that working bench, this is a typical working bench, and in this working bench, basically bench top, this kind of bench vise, all these things are actually fixed. Okay, and over that surface one can place the particular job, and you can work on that. Now what is the bench vise? Bench vise is basically this kind of a thing where wood piece where you want to work, that particular job is fixed, and after that different kinds of operation is done. Here you can see one of the there are two rests, and one of them is the moving one, another one is the fixed one, and with the help of this handle we can move this particular jaw either inside or outside, and this is operating by a screw nut mechanism, as you can see here. Okay, so if you rotate this particular handle in a clockwise direction, definitely it is going to move in the direction of the fixed rest, and if you move in the anti-clockwise direction, it is moving in the opposite direction. Okay, and here in this picture you can see that by rotating this particular job is fixed, and after that maybe some cutting operation will be done. Now next one is the C clamp, or this is also sometimes called as the G clamp because of the shape of the clamp. As you can see, both are basically the same thing, and the different components of the C clamp or the G clamp shown here. This part is called the anvil, this part is called the shoe, and ball and socket, screw. This is also working on a screw nut mechanism. Okay, and this length is what is the throat length. So now this is used when it is required that two pieces of maybe the two workpiece, let us consider this is workpiece, this is another workpiece, and with the help of some adhesive, suppose you want to join with the help of some glue kind of a thing, some adhesives, you want to join these two wooden pieces. So after applying the glue or the adhesive between these two job, then it is required to give some compressive force, and that you have to keep that for a very long time maybe. So for that this kind of C clamps may be used. Okay, so here you can see that not a single C clamp, basically number of C clamps actually used, so that and kept in that form maybe for a long time, and after that maybe some operations can be done. So this is one of the use of the C clamp, to give some compressive force on the joint here. Now coming to the next, it is the cutting tools, and there are different kinds of cutting tools that we use in the carpentry shop, like saw, chisel, jack planer, and we'll see one by one. So first of all, we'll see saw. Here you can see that with the help of saw we know that the cutting operation can be done, and that particular operation what we do with the saw is called the sawing operation. Okay, so that operation is called sawing. Now the important thing is the different parts of a typical hand saw. Okay, basically in woodworking, what kind of saw we are using is basically called the hand saw. Now here you see that this particular part is what is called the toe. On the other hand, this is called the heel, and here you can see this is the back side of the saw, and this is what is the front side of the saw. And on the front side you can see that there are teeth like this. Okay, and this is what is called the blade, and definitely this is the handle. So these are basically the important parts of a hand saw, typical hand saw. Now in the blade, if you look carefully at the front end of the blade, there are teeth. Now this teeth profile, if you see carefully, depending upon the teeth profile, we can give the name of the saw. So this is a very, very important thing. So there can be either crosscut teeth, or it can be rip teeth. So there are two typical type of tooth profile which is used. One is crosscut and another one is rip teeth. So what is the difference between crosscut and the rip teeth? Crosscut teeth and the rip teeth, if you observe carefully, in case of a rip teeth, where you observe a typical single teeth, if you observe, it is kind of, that means if you just consider this 90-degree line, this angle is very, very small. This angle is very, very small, even less than 10 degree. Okay, this is a very small angle. So the whole angle is approximately 60 degree. The whole angle is approximately 60 degree. That means from this end to this end, the whole angle is 60 degree, but this is almost 90 degree. This is almost 90 degree. This is almost vertical, and one end is basically slant. So this is what is the typical rip teeth. Okay, so this is what is the typical rip teeth. So basically this rake angle is very, very small here in case of a rip teeth. That is why what happens, this end, basically the handle is there in that side, and if you move the teeth in this direction, then you see it is facing the wooden surface with this 90 degree kind of a teeth, almost 90 degree kind of a teeth. Okay, so definitely it will cut in the forward direction, but when you just move it in the opposite direction, then you see that in the opposite direction these are slanted. So when it is moving in the opposite direction, then because of this slant, it will just slip over along the slant. Okay, so that is why in the backward stroke there will be no cutting. Only in the forward stroke there will be cutting, if the teeth is like this. So this is kind of a forward cutting rip teeth. Okay, if you just make it opposite, that means the rip teeth, if you cut in this way, then what will happen in the forward direction, it is not going to cut, only in the backward direction it will be cut. So that is the only thing you have to remember. In case of a rib teeth, it is basically one way cutting, only in one direction it is going to cut. Okay, now coming to the cross cut teeth. In case of a cross cut teeth, if you look carefully in the profile, now the rake which is provided is much higher with respect to the rib teeth. In a rib teeth, I have told it is only about 5, 6, 7, 8 degree, not more than that. But in case of a rake teeth, this angle is around 16, 17 degree. So almost 20 degree angle is there. You can, so around 16, 17 degree angle is there, and here it is around 45 degree. So here if it is around maybe 15 degree, and here it is around 45 degree kind of a thing, 45 and it is around 15. So the total is again 60, but now you see that inclination is there both in the forward direction as well as in the backward direction. That is why what is going to happen, that in this kind of a cross cut teeth, both in the forward direction as well as in the backward direction, there will be cutting. So cutting will be there in both forward and the backward direction. So this is what is the cross cut teeth. Okay, so now in case of a hand saw, if it is a cross cut teeth or if it is a rib teeth, that you have to observe looking carefully into the teeth profile. Accordingly, the name is called like cross cut saw or a rib saw. That depends completely what kind of teeth profile is there. Now next we'll see that this is called the Tenon saw. So in this Tenon saw, as you can see, there is, you can see a metallic support there over the blade. There is some metallic support. So what happens if there is cross cut teeth in the blade, and this kind of metallic support helps not to bend this teeth sideways. The lateral movement of the teeth is supported with this. This can be made of brass or some other materials, so that it support the blade movement. Okay, so that blade movement does not takes place. So blade life basically increases because of this kind of supports. Okay. And what is another difference, as you can see, the shape is kind of a parallel. Throughout the shape is parallel. Previously we have seen a typical kind where the shape was gradually tapered, right? So here you see it is a parallel. Now what are the specifications of any hand saws? The specification, you just remember, specifications are basically identification, so that you get that particular hand saw. And for that, one of the specification is the length of the blade. So length of the blade is basically from this end to this end. So here in this example you can see it is 254 millimeter to 355 millimeter. That is the typical length of a typical Tenon saw. Okay, and if the length is in the order of 200 millimeter, that means shorter one, as you can see here, and this is called the dovetail saw. Okay, this is called the dovetail saw. And one is the length, that is one of the specification. Another specification of the thing is the how many teeth are there in 1 inch. Okay, so the density of the teeth is one of the specification, and density of the teeth is expressed in the unit TPI. TPI means what? TPI means teeth per inch. That means in 1 inch length, how many teeth are there? You have to count how many teeth are there, or how many points are there, all the same. So PPI or TPI, these are all same thing. Okay, PPI means points per inch. Okay, or teeth per inch are the same thing. So here in this Tenon saw, as you can see, the number of teeth per inch is 13 to 15. So 13 to 15 teeth per inch, that is what one of the specification, how closely the teeth arranged. Okay, and definitely the other kinds, like what is the kind of teeth profile that is present, whether it is a crosscut or a rip, so that is also to be mentioned. The type of the teeth profile, length of the blade, and the TPI, these are all the different specification. Okay, so you just remember at this point that if you have to cut a very large timber, okay, very large job, if you want to saw, in that case we generally choose a small TPI, maybe in the order of 5. Okay, maybe 5 TPI is sufficient to cut a very long job. But if you want to work on a very small job, okay, so in that case you require very close teeth. That means the TPI requirement may be in the order of 30. Okay, so it can be in the order of 30. So just to give you some idea, for a large job, then TPI should be small. For the small job, your TPI requirement should be high. To get some idea, here you can see the typical values are in the order of 14, 13, 15, like that. In case of dovetail saw, you can see the TPI is in the order of 16 to 22, just to give you some idea. Now see two more types of saw, that is compass saw. Compass saw is as you can see, compass saw is used here. The specialty of the compass saw is generally you can bend the saw to some extent. Okay, you can bend the saw to some extent during its work, maybe this kind of work you can see. And keyhole saw also, that maybe some hole that you are creating, and over that you want to fine finishing with the saw. So in those cases, this kind of saws are used. Basically, you can understand the width of the blade is so small, so that it can be inserted into the small holes. Okay, so compass saw and the keyhole saw are two again very important kind of saw for special purpose use. Now this is a typical cross-cut saw, where basically two mains are required, because the length of this kind of saw is very large. Probably you have seen this kind of operations. These tooth profiles are the cross-cut saw, and definitely the TPI for this kind of work should be very less. Now coming to another kind of cutting tool, which is chisel. Now chisel is used along with a striking tool, which is, in case of a carpentry, is called the mallet. So mallet is nothing but a hammer like thing. Only thing is that it is made of the pin that is made of wood. Okay, it is completely made of wood. So with the help of wooden this mallet, the chisel is strike over the surface where you want to work on it. Now the chisel having the different parts, if you see carefully, the different parts for a, here you can see that there is a ferrule, and through this ferrule basically it is connected with the handle. And in this particular case, here you see that there is a steel hoop, through which basically a steel screw continuously there inside it, and through which this basically ferrule is connected. And when it is required, this steel hook can be released, and the blade can be taken out from the handle, and it can be used for the sharpening, and for other many reasons are there, because of which sometimes it is required to remove the blade from the handle, or the chisel from the handle. Here you see this is the tang portion, this is the neck portion, this is what is the blade, this is the cutting edge, and this is a typical bevel edge chisel. Bevel edge means here you can see that this kind of an inclination that is provided from the top surface to the side edge. So this inclination is there. Here you can see that these are bevel edges. These are the bevel edges. Also you see that at the leading edge there may be some bevel. This is typical bevel edge chisel that you can see, the bench chisel, and these are the different parts. Now how it is connected with the handle, it can be of different kind. Here you can see that socket kind of an arrangement where you see that this particular portion simply goes into the socket. Okay, so simply goes into the socket and it can be released. And when you are working, definitely you are pushing in this direction, so automatically it will tighten. But there is always a chance if you just place it is in this way, that it is possible that this particular chisel can loosen out from the socket. So in that way it can damage its leading edge. So this is one way of connection with the handle and the blade. And another way, I just told you that this one is preferably the most useful one, or it can be also connected with the help of a tang. A tang is something like which can go up to this much inside. Okay, so this is a fixed kind of a joint. Okay, so it is not possible to remove from the handle. So there are three different connections I have shown. It can be with the help of a tang directly inserted into the handle, or it can be movable with the help of a complete screw goes into the ferrule, or it can be a socket kind of a joint which can be easily removed. Okay, but this is the most preferable one. And not only that, you can see at the end there is a steel cap. So even in those cases you can use the hammer to striking the chisel. But in case of this kind of an wooden handle, you should use the mallet. Okay, or in this case you can see that you should use the mallet, otherwise there is a chance that your handle may break. Okay, but here since the steel cap is there, so you can also use the hammer. Now let's see the different kinds of chisel. Now the first one, if you look carefully, this is the typical bench chisel. We'll see that here it is a bevel edge chisel. So bevel edge, I have already told you, as you can see there is some inclination there in this edge. This is what is the edge. Okay, so these are basically the edge. That is why it is called the bevel edge chisel, because there is inclination in the edge. Okay, some inclination is there on the edge. That is why it is called the bevel edge chisel. And also at the leading edge you can see that there is some angle. At the leading edge there is also some angle. Here in this picture you can understand that there is some angle at the leading edge also. Okay, and the bevel edge, I think you have understood that at the side edges are some bevel angle is provided at the side. Okay, now if you see the next one, which is the farmer chisel, FIRMER, farmer chisel. In case of a farmer chisel, the bevel angle is provided at the leading edge. Definitely the bevel angle is provided at the leading edge, but there is no bevel angle provided at the edge. At the edge there is no bevel angle. So that is why it is not a bevel edge chisel, because the edges, these are basically the edges are 90 degree. Okay, so edges are 90 degree to each other. So here you can see the plane edges. So these are farmer chisel. Okay, plane edges. So you have understood the bevel edge chisel and the farmer chisel. Next we'll see the pairing chisel. The paring chisel is typically a kind of chisel which is also a typical bench chisel, but the leading edge angle is very high. Leading edge angle is in the order of maybe this, that means the leading edge angle, that means leading bevel edge angle at the front, this angle is very small. Okay, this angle may be in the order of what, maybe 16 degree, 17 degree, like that, only 16, 17 degree. Whereas if you see the Mortis chisel, in case of Mortis chisel, the angle is in the order of 30 degree. Okay, and typical in case of a bevel edge, the bevel angle is, the angle is of the order of 25 degree. So you can understand, in case of a paring chisel, in case of paring chisel, this angle is very small. So if the angle is very small, in that case it is suitable for the fine work, for the finishing work. And when these paring chisels are used, actually hammers are not used. It is generally used with the help of hand. Simple light push with your hand, it is used to do the final joining or the final finishing part can be done. Okay, so that is why this angle is very small, and that is very sharp and small angle, and the soft wood can be easily removed with the help of paring chisel by light blow of your hand only. Okay, no hammering is required by mallet or any hammer. But that operation is also called the paring operation. Okay, paring operation, the finishing kind of an operation done with the help of a chisel. On the other hand, if you see the Mortis chisel, see that Mortis chisel is also like farmer chisel. There is no bevel at the edge. There is no bevel at the edge. It is a plain edge, as you can see, 90 degree. But if you observe that it is generally very thick. If you see from the other direction, you will find that this is thick and long. Generally this is thick and long, and at the leading edge, the bevel angle, that is given is very high. Leading edge, the bevel angle is very high, 30 degree. So this is suitable for the chopping operation. Okay, this is suitable for the chopping operation. I will show you in the video what we mean by the chopping operation. That means metal removal, and for when the high strength is basically required. You can understand that if the edge is with a small angle and edge with a high angle, definitely when the angle is high, then this particular edge is much more stronger. This is much more stronger than this particular edge. Okay, this is not so stronger, but this edge is very stronger. So when high strammer, when high blow is given with the help of a hammer to chop off some metal, some wooden chips, in that case basically the Mortis chisels are used. On the other hand, I have told you that for the paring operations, like very fine finishing work, then this kind of a very small angle is provided, like 16 degree for the paring operations. But in case of a bevel edge chisel, you can do any operations, both chopping and the paring operations actually can be done. Okay, so now you have understood the different kinds of, these are the 4 important types of chisels that you have to remember their name, and you have to identify those chisels when you see the actual one. Now let me show you this video.
First up is the most common and most widely used chisel, and that's the bench chisel. It gets its name because it's often found sitting on the workbench because it gets used so much. Bench chisels have a 25-degree primary angle on the blade, and they do come in a few different options. The first option, and maybe the most common, is the beveled edge chisel like this one here. If you look close at the edge of this chisel, you can see that the edge is beveled and not 90 degrees to the top. This particular bench chisel has a fine edge bevel, meaning that the bevel goes almost all the way down, creating a very small 90-degree edge. However, if we look at this other beveled edge chisel, you can see that the bevel or relief angle doesn't go as far, and it leaves a wider 90-degree edge. One of the reasons why people generally prefer a bevel edge is because it makes it possible to fit into tight corners like that produced when cutting a dovetail. The second option is what's called a firmer chisel. I don't have a firmer bench chisel in the shop, but the edge would be square or 90 degrees, similar to this one here. Bench chisels can do almost any task, and they're great for both chopping and paring. And if you're not familiar with those terms, chopping is when you remove large amounts of material at a time, and you would generally be using a mallet for this task. Paring is when you remove thin layers of material. While using just the strength of your hand, there's no need for a mallet here. Paring is used often when you're at your final stages of fitting a joint and you just need to remove a little bit of material to get the joint to fit perfectly. Again, bench chisels are great for both chopping and paring. That's why some people think that there's no need for any other type of chisel. Next is the Mortis chisel. At first glance, you can see that it has a 90-degree edge, and the steel is much thicker and more robust. On closer inspection, this Mortis chisel has a 30-degree primary bevel. What this does is gives the leading edge of the chisel a little more strength. Look at it this way: the steeper the angle, the stronger the edge. The shallower the angle, the weaker the edge. And you'll see an example of this when we get to the paring chisel. The mortise chisel is designed to chop mortises, which require a lot of force, so that edge needs to be strong. The combination of a thicker, more robust steel, a steeper bevel, and a slightly longer overall length makes the mortise chisel the perfect design for handling this work. The next chisel is a paring chisel, and the one I have here is a custom chisel that has a primary bevel of 17 degrees, which means that the edge is very fragile, but it does a fantastic job at paring end grain in softwoods. Again, paring chisels are designed to be used mostly by hand to push them through the work, unlike using a mallet for the other chisels. Paring chisels generally come longer, and they have longer handles so that you can have more control when you're using the tool by hand. Now, the one I have here is not the classic looking paring chisel, but they do come in many different shapes.
So I hope you have understood that how to use the different kinds of chisel and their types. Next we'll see the specification of the chisel. So already you have seen that one of the specification definitely the type of chisel. Another specification is the kind of joining process with the handle, and here you see the specification that has been shown in this diagram, that is the width of the leading edge of the chisel. Okay, so based on that also chisels are specified. So this width is 1 inch, so that is why this is 1 inch chisel. 3/4 inch chisel, so this width is 3/4 inch, so it is 3/4 inch chisel, like that. Okay, so this is the width of the leading edge is another specification of the chisel. Now it is important to know about the material of the chisel. Remember that the chisel material is made of tempered high carbon steel. Okay, high carbon steel, tempered high carbon steel. So high carbon steel are actually very hard material, so that directly cannot be used after hardening process. Generally, to impart the ductility, this tempering is done, tempering operation is done, because when chisels are used, it is used with the striking load. That means the shock load is coming on the material. That is why some amount of ductility is to be imparted, so that the toughness of the material increases, and that is why tempered high carbon steels are used in case of chisels. On the other hand, in the saw that we have seen earlier, those can be made of high carbon steel. So for these cutting tool materials, you remember the cutting tool materials in the carpentry shop that we are seeing, these are made of high carbon steel. Only in case of a chisel, where we are using the striking load, since this kind of high toughness is required, that is why some amount of ductility is required to be imparted. That is why the chisel material, you remember, is tempered high carbon steel. Now coming to the next cutting tool, which is planar. So planar, this operation probably you have seen, initial rough cut is given to reduce the dimension. This particular operation is called the planing operation, and it is done with the help of this planar that you can see, and this is in carpentry shop is called the jack planer. So jack plane is this thing, and the different parts of the jack plane has been shown here in this diagram. As you can see here, this part is called the toe, this part is called the heel, this is the handle, okay, and this is what is the blade, this is the lever cap. So these are the things that, and there are the adjusting levers or adjusting nuts through which the longitudinal adjustment or the lateral adjustment or the depth adjustment, this can be done. So what is the function of this thing? Let us try to understand with this video.
Everyone, and welcome to Bob's Wood Stuff. Today we'll be talking about how the chip breaker on a hand plane works, also known as the cap iron. We'll start by looking at an X-ray view of a hand plane. This piece is the chip breaker, aka the cap iron. It attaches to the plane iron or blade with a flathead screw. Let's take a look at what could happen without a chip breaker. The tip of the plane iron acts as a wedge, which splits the grain ahead of the blade. This can cause chip out, resulting in an uneven wood surface. This same phenomenon happens in a similar way when a log is split by an axe. The split in the log goes farther than the front of the blade, following the direction of the grain. Now let's see how it works with a cap iron to act as a chip breaker. As the wood is split by the plane iron, the shaving hits the chip breaker, crumpling the grain. This prevents it from splitting in front of the blade, minimizing chip out and resulting in a smoother surface. To make fine shavings, put the cap iron very close to the tip of the plane iron, to the point where there's just a little bit of blade showing under the cap. You will also want to make the mouth of the plane small. Move the frog forward using the frog adjustment screw. This is called longitudinal adjustment. This is the setup you want for a smoothing plane, or if you are in a plane shaving contest. For a rough plane to remove a lot of stock, like a jack plane or a scrub plane, you'll want a different setup. Move the cap iron back a bit. Open the mouth by moving the frog back. Lower the blade with the depth adjustment nut. This setup allows for easy removal of a lot of stock, but is not good for fine smoothing. Thanks for watching.
So I hope you have understood that how to adjust the main plane iron and the cap iron, and cap iron actually acts as the chip breaker as been shown, and the different adjustments are like the longitudinal adjustment, depth adjustment, and the sliding of the cap iron over the plane iron. So these are the different kinds of adjustment that is done to fix the blade and the chip breaker, so that you can make it for a rough cut or a smooth cut on the with the help of a jack plane. Now coming to the another cutting tool, which is the drill, and there are different kinds of drill that is used. The first one, as you can see in the picture, this is gimlet drill. This gimlet drill is actually used with the help of a hand. So initial hole is required for insertion of a nail or a screw. This kind of gimlet drill are used. Hand machine drill, as you can see that with the help of this machine drill the hole is created. And the hand drill, where it is a completely mechanical device, where with by rotating this particular wheel here with the help of this handle, you can see that the rotation direction actually is changed, and that is done with the help of a bevel gear set, as you can see, which is there. You can see the back view of this, and finally that is rotating the reel which is fixed at the end. Okay, so this is what is the hand drill. Now coming to the striking tool, there are different kinds of striking tools, and those are actually varying based on the kind of pins that is there. So the different parts of the striking tool, as you can see, this is the handle, you see this part is the eye, this is what is the claw, this is a claw hammer, so this is the claw, and this is cheek, this is head, this is the throat, okay, this is the face, and this is the neck. These are the different parts of a hammer. And now see the different kinds of pin that is there, and based on that different kinds of hammer, that is the ball pin hammer. Here see the pin is PEEN pin, so that pin is basically the ball pin, and this ball pin is used for the when it is a very small size something on which you want to strike, very the space is very small, and then ball pin is used. Or if you want to change the shape of some sheet metal, sometimes that is used, or some now coming to the cross pin hammer. So again, cross pin hammers are used when some sheet metal work to change the shape, or maybe on a small pins or something where the area of cross section is very small. In that case, this kind of cross pin hammers are used. Now straight pin hammer, as you can see, after that that is also this kind of a straight shape is there. There is a straight pin hammer. And the claw hammer is the most popular one, as one end you can see for the striking, and the other end is used to remove the nails or pins from the surface. Okay, this claw end. And the sledgehammer is used for the large blows, huge blows, generally used for demolition works. And the mallet, already you have seen, this is made of wood, and it is used in case of chipping operation in carpentry. Now coming to this one is the pincer, and you can understand that pincer is used to remove the nails here. Okay, so that is what is the use of the pincer. Now coming to the finishing tools, and finishing tools can different kinds of files are used for the finishing operations. If you look carefully, the within the file there are basically the teeths, and depending upon the arrangement of the teeths, they are called either single cut teeth and double cut teeth. If you observe carefully, this is the single cut because these are aligned like this, so these are single cut. In case of a double cut, if you observe carefully, the teeths are aligned both in this direction as well as in this direction. Okay, so this is a double cut teeth, and it can be like a carved tooth, as you can see here, depending upon the shape of the surface. So this is the carved tooth, or it can be rasp. Okay, in case of a rasp, basically the large pockets are there, large triangular pockets are there. So for the large material removal, respectively large material removal, the rasps are used. Now the different parts of the file, as you can see in the figure, like this end is called the tang. Okay, and this is what is the length. Remember, this length of the file is one of the specification. Definitely the kind of teeth cut that is there, the density of the teeth, all these are specifications. and here you see this part is called the face, this is called the edge, this is called the point, this is called the heel. So these are the different parts of a file, typical file. Okay. Next we'll see that different types of file and their use. If you see carefully that already we have seen there can be two types like single cut and double cut file, and single cut are used for the precision work and double cut are used respectively for the first wood removal. We use the double cut, but for the precision work, remember, single cut is used. Now both single cut and double cut, depending upon the density of the teeth, it can be of four types. Like they can be coarse, they can be bastered, or they can be second, or they can be smooth. So depending upon the density of the tooth, whether it is a single cut or a double cut, it can be single cut coarse or it can be double cut coarse, it can be single cut bastered or a double cut bastered, like that. So coarse, bastered, second and smooth are depending upon the density of the tooth that is present. So coarse is used for the first wood removal, the bastered is used for the medium first wood removal, second is used for the medium wood removal, and the smooth is used for slow wood removal, for the smooth surfaces. Okay, so these are the different types of the cut that is there, and the different kinds of gradation depending upon the density, and finally you see that depending upon their shape of the cross section, again file can be of different kinds. As you can see in this picture, it can be half round file, or it can be triangular file, it can be flat file, it can be square file. So different, this is a full round file. So there are different kinds of file depending upon their cross section is also graded in that way. Okay, and this is a typical picture of a rasp. As you can see that the triangular large pockets are there, so that after you are doing this kind of finishing operation with the help of a rasp, then what happens, the chips actually stays there within these large pockets. Since the pockets are large here with respect to the files, so definitely the material removal rate is better in case of more in case of rasp. Now finally we'll see the safety rules in the carpentry shop. So wear safety equipment always. By safety equipments we mean it can be apron, it can be goggles, it can be your proper shoe, proper dress. So all these things includes in the safety equipments. Now avoid alcohol and drugs in the carpentry shop. This is very, very important. All the time you should be conscious. Always disconnect power after using any power tool. This is very, very important. Never put your hands close to the moving blades when suppose you want to cut with the help of machine operated saw instead of a hand saw. Suppose you want to cut with the help of a machine saw, in that case you know that this kind of a sawing teeth which is continuously moving, okay, suppose it is moving in this direction, okay, and you are feeding the job in this direction, so you have to push it, okay, definitely to cut that operation. So never put your hands close to the moving blades. So note this thing, that do not keep your hand close to the moving blades, that is important. So keep the safe distance. Now always use sharp blades and bits. This is important. When you are using any drill bit, that drill bit should be sharp, or if you use any always use the sharp blades, okay, otherwise there is a chance of accident. Always work against the cutter. So if this kind of a machine operated cutter is there, so always cut against the cutter. So always feed the job in a direction opposite to the direction of the cutter. Against the cutter you have to feed, not in the same direction. Work in right clothing, that is very important. Always wear the tight clothes. Do not wear anything which is loose, so that those can go into the machine, those can stuck into some places. So always use the tight clothes, that is very very important. Always put covered shoe, these are important. Keep your workplace tidy and equipment well maintained, this is very very important. Always keep your workplace tidy, but do not all after working always try to keep everything but put everything whatever you have used, all the tools in the right place. Do not put things here and there. You have to keep watch on the floor properly, whether anything is there on the floor that might create any accident like the nails or anything. Okay, so you have to keep watch all the time where you are working, and minimize or better yet avoid any kind of distraction. Do not talk unnecessarily within the workshop, within the carpentry shop, this is very very important. And always be focused in your work, because most of the accidents actually takes place because of this kind of distractions. Okay, so thank you.